time taken to travel the distance.
The speed also changes when we apply the mass to the substance, which will also impact the time taken to travel the distance. Do you know what will happen to the speed when we increase the mass over the same distance?
That's a good question, Rashmi. Why don't we just try carrying out this experiment?
Absolutely!
A very good morning to the honorable judges. We are from SJKT Castle Pocho. My name is Divesh and these are my team members Rashmi, Maidili, Aishwarya and Jishnu. Together we are known as the Junior Einstein team. Our project title is to study the effect of mass of a substance on the substance's speed. The problem statement is, how does the mass affect the speed? Our objective is to investigate the relationship between the mass and the time taken to travel by the object at a fixed distance. Our hypothesis is, the higher the mass, the higher the time taken for the substance to travel at a fixed distance. The manipulated variable is the mass. The responding variable is the time taken for the substance to travel. The constant variables are the height of the flat surface, the type of surface, mass used to create force for the moving substance, and the distance travelled by the moving substance. The external factor for this study is the wind.
The apparatus used in this experiment are stopwatch, measuring tapes, weighing scale, scissors, double-sided tape, electric drill, glove, ruler, and screwdriver. The material used are used mineral water bottles, empty shoe box, skateboard, sand and stones, plywood, used pulley, mounting board, dumbbell weights, nylon string, broken chair legs, and used curtains. We went through a few challenges in building our model to test the speed. At first, we did a 30-degree ramp and tested the travel time, but we got inconsistent results. After further investigation, we noticed that the friction in the ramp has a bigger influence in this setup instead of the various mass used. Thus, we came with this new design. But even with this model, we still faced a few issues.
Let me explain about our innovative flat surface. This is a flat surface that we are going to test the speed with different masses. The total length of this flat surface is 122 cm following the table size, and the width is 53 cm. Initially, when we built this flat surface, the height was not enough for the applying force to pull the trolley for 65 cm. Therefore, we increased the height of this flat surface by using broken chair leg and plywood. We also covered this flat surface with carton box. The initial height was 74 cm, but after the improvement, it increases to 95 cm. To make the flat surface smoother, we stick marking board on top as well. Everyone, please see this. This is the starting point and this is the ending point where the trolley will stop. If we minus 85 issues while handling the materials. Number 3, handle the heavy objects in care. Okay, now let's start our experiment. As explained just now, we are going to measure the speed at a fixed distance for each mass. Now, I will be calculating the time. Reshmi will collect the data and then Jisnu will let go the trolley. As the first step now, Jisnu will place the trolley which has a mass of 1 kg at the starting point here. Secondly, Jisnu will then let go the trolley. Thirdly, I will calculate the time from the starting point to the ending point. This method will be repeated 5 times for each mass to get the average reading. This will be continued for every 1 kg additional mass. My friend Reshmi will then write the results after we measure each time. Let's start our trial.
First, we are going to start the experiment with 1 kg mass.
0.75.
Now we are going to test 2 kg of mass.
Start. 1.03.
Now we are going to use 3 kg of mass.
Start. 1.32.
Now we are going to test 4 kg of mass.
Start. 1.62.
Now we are going to use 5 kg of mass.
Start. 1.91.
Now we are going to test 6 kg of mass.
Start. 2.38.
Now we are going to test 7 kg of mass.
Start. 3.10.
Now we are going to test 8 kg of mass.
Start. 3.69.
Now we are going to test 9 kg of mass.
Start. 4.70.
Now we are going to test second trial for 9 kg of mass.
Start. 4.38.
Now we are going to test the third trial for 9 kg of mass.
Start. 4.43.
We are going to test the fourth trial for 9 kg of mass.
Start. 4.12.
Now we are going to test the fifth trial for 9 kg of mass.
Start. 4.22. Dear judges, this is the final result after repeated trials for 9 different masses. During our trial, we observed that the time taken to travel by the trolley increases when we add the mass, which can easily seen in this graph. Please see this. The time taken to travel increased for every additional 1 kg of mass. When we convert this to speed by dividing the distance over time, the speed has reduced when the mass is increased. Dear judges, our study shows the higher the mass, the time taken to travel increased at a fixed distance. Therefore, our hypothesis has been accepted. It also has shown when the mass increases, the speed decreases.
Dear judges, from the results of the experiment and the graph of the mass versus time and mass versus speed, similar calculation done via Newton's law of motion, the obtained results show similar outcomes between our observation and the theoretical results. However, our results indicates a longer time taken to travel at a fixed distance against the calculated value via the Newton's law of motion. This is mainly caused due to the friction force on the trolley, the flat surface, the pulley, and may also be caused by the external forces such as wind. This caused the speed of our study to be lower than the theoretical calculation.
From this experiment, we can relate the outcome of this study on what we observed in schools. Students often carry heavy bags to school every day. Such heavy bags hinders the students from reacting faster in time of need, especially when they are running away from danger. Therefore, lighter bags will help the students to move faster and also can save lives at times. Besides the school bags, modern day cars are designed with lighter but yet stronger materials to give the car a better fuel economy and speed. This is a good example of the outcome of our study today.
In order to minimize the error, we can actually improve our experiment by adding a stopper at the starting point. This will make sure the distance between the starting point till the ending point of the trolley is controlled.